Alright guys, thank you for watching. This is the coding teacher. I'm here to teach you how to code. The thing that I'm going to do today is I'm going to live code Flappy Bird. So I'm actually done with it. I already recorded all the videos. So I kind of thinking about it how I did it. I fumbled around a little bit. I hope that you find that informative in order to see kind of like what my thought process is behind things as I go ahead and do them. The first time around, I've actually never made Flappy Bird before. I've made probably dozens of games, but I've never made Flappy Bird. So there's just some certain kind of patterns that are repetitive to games, so that's how come I could already go ahead and live code this stuff. But I hope that the fact that my explanations are very superficial, I don't stop for a long time to explain anything, but I do show how my thought process works and how I go through, make mistakes and think of something and then it's wrong and then I change it. I hope that's informative to everybody, and certainly you feel free to go ahead and use this code and enrich it and add anything that you might want to add to it. Alright, we're going to start making some Flappy Bird going on here. I already got all my sprites ready. I'm going to start by creating a new index.html, and I'm going to explain a little bit about what the canvas is. What the canvas element is all about. So first things first, let me get a canvas element up in here. Flappy Bird. And I'm going to create canvas id equal canvas, and if you want to be lazy, you can do the width and height right here as attributes. One thing that does not work is styling the canvas with CSS. So let me show you the difference between that. So let's say that actually I'm gonna get into the difference between styling with CSS. In a nutshell, styling with CSS stretches it. So the default canvas size, I believe, is 300 by 300, and if you style it with CSS, all that does is stretching it. So all your stuff is going to look warped and fuzzy. So don't do that. Don't style with CSS. You got to set width and height attributes, or you got to do it the way that I'm actually going to do it, which is I'm going to size the canvas with JavaScript. Script circ main.js, and then I'm going to create that. Actually, I'm going to go create a separate subfolder, new folder, JS, new file, main.js, and in here I'm going to create just two global variables. Canvas equals get element by ID canvas, and I'm just gonna size that sucker now. So c dot width equals window dot inner width. The window dot inner width is the width of the actual viewport, and c dot height equals window inner height. Actually, no, I can't do that because my own version of Flappy Bird have this background image, and this background image, if I recall correctly, let me see, is 600 pixels tall. So c.height is gonna be stuck being 600. And now if I go back and inspect my page, I have my canvas. It's at 300 by 150. Don't really understand why. Oh, C is not defined. Oh crap, is that call? Alright. see, there we go. So now the thing is the whole um, window, but we see we have a little problem. We can scroll sideways. If you look at the scroll bar down there, you can scroll sideways, and if you notice, it's because there's a little bit of padding. You see the canvas doesn't start till a few pixels in. I don't know why, but HTML and web browsers have that nonsense, but all we gotta do is body padding 0. When we refresh, margin 0. There we go. Now we can scroll sideways. Another little hack I guess we could have used was the overflow hidden. So we don't, I guess we don't need the, we might as well keep the padding just in case there's some browser I don't know about that has padding to the body. Now that we have that, at this point I normally go over like a little explanation of what Canvas is in general. And there's basically, most programming languages have some kind of entity that you can draw shapes and images on, and in the case of JavaScript, that's Canvas. In the case of Java, there's also a canvas and there's a JPanel. But basically, think of your drawable element and think about your computer's graphic card, right? And then there's always some kind of like weird object thing, which is the interface between the computer's graphics card and the element. So you use this object. This object is the one that's going to have the methods to draw lines, rectangles, curves, images, and everything on the canvas. And in the case of JavaScript, that object is called the context. So usually people call it CTX. So we're going to say const CTX equals C dot get context. Let's put a capital right here. 2D. And now that we've said that, we can use one of the methods, ctx dot draw image, or no, let's start with fill rect, and let's say that it starts at 0, 0. Actually, let's have it start at x coordinate 100, y coordinate 200, that the width is going to be 400, and that the height is going to be 150. So that's the way that it works. Fill rect is the first number, it takes 4 parameters. The first number is x coordinate, the second number is y coordinate, the third number is width, and the fourth number is height. So we reload, now we have our rectangle there. And now I'm going to show you what I was talking about. Let's say that I didn't do this, and instead I had tried to style my canvas with CSS. Canvas, let's say width 100%, and height, say 600 pixels. And now, oh, so I have to draw this thing closer to 0, 0. It has to be smaller because it's actually getting stretched and it's off the screen. So you see, it takes up the entire screen. I'm going to make it a smaller. I'm going to make it 20 by 5. And there's my fuzzy ass little square. So if I put it at 20, 20, you're going to see now. So I get this fuzzy little square, and in fact I'm actually going to make it 20 by 20 so that you see that it's warped. It's actually not a perfect square. It's a little bit wider than it is taller. And that's all because of the stretching of the canvas that's occurring due to CSS. So I'm going to delete that and get back here, so that we see that now I get a sharp, nice square, and it's actually the correct size. You know, it's 20 by 20. It's tiny, and you know, so avoid sizing canvases with CSS. Now, so that's an example of fill rect. If I wanted to change the color of the next thing that I use fill anything on, I would do ctx dot fill style equals, and I put a hex color. So let's say that I want green. So ff or 00 ff 00, and there we go. Well, I haven't actually painted anything, so now I gotta do another fill rect. it at 100 by x 100 y 20, and it's also going to be 20 by 20. So now we have another green square, and if I want to change the next thing that I paint to, I don't know, blue, I'm going to do this. I change the fill color to blue, I paint another one, this one's going to be a 200x, and there we go, so we have three little squares. Now there's another method that you can use, ctx dot stroke rect, and that one we can say 320 20 stroke rect just draws the line with a stroke, so it doesn't actually fill it, it just draws a little box. If we want to change the stroke color, we can do ctx of the next thing that we draw, that stroke style equals let's say black, or let's just say red. And now I have to paint another thing. I keep forgetting that I'm not actually painting anything. 400 right here, and then we have our stroked rectangle. So with fill rect and fill style and stroke rect and stroke style, we can draw rectangles whenever we need to, and that's going to come in handy because you wouldn't believe how much stuff you can actually draw on a screen. Now, to draw an image, that's the kind of, I figured out a way that I like. I don't know if it's good practice, it might be a hack, but I like it because it's simple. So normally what you have to do if you want to load an image is you have to do some kind of thing like this. Const bird1 equals new image, right? And then bird1.src equals, and then I have to link from main.js to bird1, which would be dot dot slash images slash bird1.png, because it's right here, bird1.png. And after I do that, then I have to have a call, because this is an asynchronous operation, it actually goes and loads the image asynchronously. I have to have a callback that says bird1 dot onload equals function, and then once I load it, that's when I can draw it. I can say ctx dot draw image, and I can put bird1 let's just draw it at 500 x 200y or 20y, and see console bird1 is not defined, and alright, it failed because I'm running a file protocol, so I guess I'm gonna have to install a server here. And so I'm installing my reload package. I could install HTTP server too, I guess. I'm gonna create this script while this thing installs. Start. There's gonna be reload B. Start my script. This, I don't know why. There we go. So now we have the web server running, the image, and I use this image method so infrequently that I didn't even remember that you needed to have a web server running for that stuff to work. Let's just real quick demonstrate how, if we have this, I'm fairly certain that it's not going to work because the loading, dude, are you serious, man? You see the loading is asynchronous, so this actually doesn't work. I have to put my drawing, like the loading, the drawing of the image on the canvas is asynchronous. There we go. Okay, so now on with the actual way that I like to do it. I like to come into my index.html. I just feel this is simpler and cleaner. it doesn't matter where, after the canvas, before the canvas, I'm actually going to insert an image element. Image circ, that's going to be images slash bird1 dot png, and I'm going to give it ID bird1, and then I'm going to go with bird2 and bird3, bird2 and bird3. And now obviously you don't want like actual image elements. This is getting really annoying. I'm gonna have to figure actual image elements sitting right there underneath your canvas, right? You don't want these image elements sitting right there underneath your canvas. So all you gotta do is hide them. Image display none, and yeah, I'm gonna stop the video right here and try to figure out what the hell is going on with this nonsense. So be right back. Alright, I'm back. I mean, I couldn't really fix it. I just changed the port. Too lazy to figure that stuff out right now. So anyway, where was I? Oh yeah, I need to get rid of this now. And what I do now is basically all my code, if all my code is inside a window on load event, window on load actually, if I'm not mistaken, waits till everything has loaded. So it's not like document ready that just kind of waits until the DOM has been rendered, even if images haven't been loaded. Window on load, I believe, waits until everything is loaded. So from here, I should be able to say ctx.draw image document get element by ID bird1 at, where was it, 520, and there we go. And I can draw another one, bird2 at 720, and there we are. So yeah, so that's the way that I prefer to load resources. I just feel it's so easy, and that way you don't have to be firing a ton of AJAX requests and keeping a counter of how many requests have been fulfilled, or a Boolean array. There's a couple of patterns that you can do, but definitely at this stage in the game, I don't want to be teaching students any of that. I want them to focus on like the basics. So normally don't really go into that. Now, what am I gonna do? Okay, so I'm gonna go ahead and start focusing on animation. So first, I'm just gonna create a bird class. Let me think. What am I gonna do first? Should I do the background first, or should I do the bird first? I'm gonna do the background first. So class environment. You know what? I'm gonna just use var or const environment equals a function, right? And the environment is going to be comprised of the foreground and the background. So I have to insert those two images here as well. And basically all the background is going to do is it's going to scroll left. So little by little it's going to scroll left. The foreground is going to scroll a little bit faster than the background. I don't actually have a foreground right now, I just realized. Images are C, images bg dot png, id bg, and then image src images, I don't know what it's going to be called yet, id fg foreground. So let me see if I can Flappy Bird foreground. If I can quickly find it, I might have to pause the recording. So this stuff is no good. do this with background only, and the student can basically add another foreground image to this environment class, can add a foreground image here to the game and render it from the environment class the same way that we render the background image, and create the foreground themselves. So what's this thing going to have? This dot pause or bg pause equals 0. This dot fg pause equals 0. So that's for the foreground when the students implement it. And oh yeah, this dot bg image equal document get element by id bg, and then environment dot prototype dot update is a function, and update is basically what's going to move the background. This dot bg pause, actually I'm gonna add another variable here, this dot speed or bg speed equals, let's call it 10. bg pause is dot bg speed. Okay, and then environment dot prototype dot render is a function, and it's gonna be this dot no I'm gonna pass the ctx here, ctx dot draw image, this dot bg pause 0, and I need the actual image, this dot bg image. So I'm drawing the environment background image at background pause, comma, y coordinate 0. So once I have that class, let's take a detour for a second and talk about in general what a game is and why I made this update and this render methods. I have a little readme that I wrote for Udacity that they never, I mean they just neglect the hell out of the pull requests, so I spent all this time writing this stuff for them and they never got around to adding it. But this is another game that I've made before. So let's look at analyze this screenshot right here, what's going on. Basically, a game is just a collection of entities. They all have a state, and it's an infinite loop. A game is an infinite loop where every time the loop comes around, you're just calling update and render on every entity. So in order for this projectile to move slowly here, all you gotta do is have a velocity x that moves it a little bit left, a velocity y that moves it a little bit up, and that's it. And the update method of the projectile, you're just saying, hey look, the y coordinate is equal y coordinate plus velocity y. So if the velocity y is a negative amount, it's going to go up. The x coordinate is equal to the old x coordinate plus velocity x. So if the x coordinate is a little bit negative, it's going to move to the left. And that's how you create an animation. You just call update and render like 100 times a second, and each time each thing moves a tiny little bit, and that's how you create the illusion of animation. The player, for example, basically what you have to do is when you detect that the player, that the human who is controlling the player hits the left arrow, for example, you give the player a velocity x that's -5, for example. And every update, the player just moves on the x-axis according to what velocity x is. So if the left key is held down, velocity x will be like -5, for example. The player is going to move left 5 pixels at a time, 60 times a second. If the up key is being held down, then the player's velocity y will be -5, and he'll be moving up 5 pixels per update, 60 times a second. If the right key is pressed instead of the left key, then velocity x will be 5 plus 5, and the player will just be moving right. Same thing with the enemy. So if the enemy, for example, is right here, and you want him to be moving over there towards the player or away, maybe it's running away from the player, right? All you're gonna do is, hey, if you want him to be running towards the player, for example, let's say the player is right here, you want the enemy to be chasing the player, all you gotta do is, hey, look, within the update method of the enemy, you have to check, tell the enemy to check if my x coordinate is greater than the player's, then I have to move negative on the x-axis this way, and if my y coordinate is less than the player, I have to move downward in the y-axis, and so on. So you do those 4 if checks for the x and the y-axis, and that's how the enemy decides to chase the player. So it's real simple. Basically, you just have to have a bunch of update methods. Every entity that you create has to have an update method and a render method that draws it on screen. So every time a game frame runs, let me actually open this in Edge so I can draw. Right here. So basically all you're looking for is that whenever I call update on this entity, right, it's just gonna, if I want it to go this way, it's gonna move a little bit here. So every time I call update and render, it'll be there. The next time I call update and render, it'll be there. The next time I call update and render, it'll be there. The next time I call update and render, it'll be there. So little by little by little, based on its velocity x and velocity y, is gonna be moving in the direction that you want it to move. Same thing for the enemy. If I want the enemy to be moving towards this guy, basically I have to say velocity y has to be some kind of positive number, so it goes down, and velocity x has to be some small positive number, so it goes this way. And that's basically the gist of games. You have one infinite loop, which I kind of outlined right here. This is basically gist of game. While true, so infinite loop, you do player.update, then for each enemy you do enemy.update, then for each of the other entities you do entity.update. So like for example, bushes, projectiles, bombs, whatever the entities you have in the game, then player.render, and then you do for each enemy enemy.render, for each entity entity.render. So render is what actually uses the context, the CTX object, to draw the thing on the screen. And so yeah, that's the basic gist of the game. And in this actual game, the background itself is an entity as well, and that's the first entity that I chose to create because I think it's like the coolest looking. So now we're gonna go ahead and create our game loop, which in JavaScript does not take this form, because if you do this while true, well, in other languages where you have multi-threading, the kind of unspoken truth right here at the end is you would do some kind of thread yield and wait for a few milliseconds. But if you did this, it would just basically be an infinite loop with no time for the canvas to actually render anything, and your browser would just crash. So what is the actual correct way of doing that in JavaScript? It's creating some kind of game loop function inside the onload. Actually, it could be outside the onload function game loop, and in here I have to how am I gonna do this? No, I'm gonna stick it inside. It's just simpler to stick it inside here. Here I can say environment with lowercase because it's the object that I'm gonna create. Dot updates and environment dot render. And now in order to set that up, what do I have to do? I have to create that environment. So const environment equals new environment, and enemy.render has to take a context object. Const environment equals new environment, and the last thing that I need to do is actually call the game loop. So let's see now. There we are. Not moving for some reason. Let me see if I just mess something up. Okay, no, it's not moving. Let's see. VG pause. So let's. Oh, in my game loop, I only called the actual loop once. So there's that next step of emulating the infinite loop. You know, this infinite loop that I have here. the correct way of doing it is calling a method from the window object, which is called request animation frame game loop. And basically, what that does, obviously, I haven't ever looked at the source code of this method or anything, but in essence, what it does is it waits until the browser has finished rendering the current frame of the canvas and is ready to render another one. So this basically goes to the event loop, and the browser gets to game loop once again when it's ready. And now that we have that, if we refresh, it's still not moving. And request, request animation frame there, and now we have that problem. So why do we have that problem? Well, let's think about it a little bit. Let's say that we have our image right here that we're drawing, right? And then we draw it again, but it's a little bit over. And then we draw it again, but it's a little bit over. And then we draw it again, but it's a little bit over. So I'm actually never deleting the old image. So how do we do that? We do a ctx dot fill rect 0 0 c dot width c dot height. Why is that? So it's basically, instead of this situation that I have right here, what ends up happening is that I draw, right, and then I paint the entire thing white, delete, and then I draw a little bit to the left, and then I paint the entire thing white, delete, and then I draw a little bit to the left, and so on. So let's demonstrate that. Blah. So of course I have to change the fill color to white before I do that. So ctx dot fill style equals no ff, and there we are. So now our animation is actually happening. Now what do we need to do here? We need to make this thing basically the render method. It can't draw it only once. It needs to draw the entire width of the screen, right? So and the update method needs to reset. So well, let's tackle one thing at a time. So let's get this drawing the entire width of the screen first. So while we need to figure out the width of the image so that we can compute, because this is the basic situation that we have. This is the basic situation that we have. We have a canvas right here, right? We have an image that we're drawing on it, right? And we want to repeat it here, and repeat it here, and repeat it here, and repeat it here, and repeat it here too, actually. So basically, we have to look at whatever this width is, and while the number of this is drawing number 0, drawing number 1, drawing number 2, drawing number 3, while the number of drawings that we've done plus 1 times this width is less than the screen width, which is this whole thing, then I draw one more. Okay? That's basically the gist of what we're gonna do. And let me see, how do I get that thing? BG right here. Let me look up the width of this. Details. 450. Alright, so 450 width. Environment. I'm just gonna put it right here. This dot width equals 450. Or this dot BG width. BG width is 450. Now, while actually I'm just gonna do a 4. 4 that I equals 0, I is less than or equal to I have to pass the canvas here. In order to have this independent, I have to pass the canvas and context here. So yeah. Yeah, there's no other way around it. This dot canvas C actually don't need it here, and don't need it here, but I do need it here. C and CTX. So here, I is less than C dot width divided by this dot BG width I plus plus. Then I'm gonna draw the image and let's see how that turned out. Field style. C is not defined where. Crap. This dot C and this dot CTX. There. Okay. So I still have a problem right here because I'm drawing at this dot BG pos plus I times this dot BG width, and there we are. So we have our scrolling background for a little bit. Now all we gotta do is reset it. So whenever we detect the situation that this dot BG pos is less than negative this dot BG width, we're just gonna set that sucker back to 0. This dot BG pos equals 0. And okay, so I need one more right here because I'm getting that blank space. All I gotta do is just say ding 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 +1, and there we are. We have our infinite scrolling background. That is way too fast, so that's why I I need to change the speed here to like 0.1. There we go. Yeah, 2 would be alright. There we are. So there we have our scrolling background. Now we're gonna go ahead and refactor this a little bit, make it a little bit more neat. So we're gonna go to here and we're gonna say script circ equals JS environment.js, and we're going to create that thing, the file. And right here I'm just gonna paste the environment. And yeah, eventually we could actually bundle this whole thing up, but right now I just want to focus on the actual code. So what's next? The bird. So let's go ahead and actually start off right and create a separate script file for the bird. Script circ.js bird.js. We go, and the reason I'm naming these with capital letters is because they're classes. File bird.js. Alright, so const bird equals function, and I'm gonna give it an x, y, so I can easily tweak where he spawns. This dot x equals x. This dot y equals y. Let's see, what else do we need? This dot vel y equals 0, and we need our update and render. Bird.prototype dot updates equals function, and all my bird is gonna do is fall. Right? Gravity's gonna pull him down. So in order for him to fall, is all I really need to do is this dot vel y. So I'm gonna emulate acceleration by this. This dot vel y minus equal, let's say 4. Okay, and bird dot prototype dot render equals function, and this reminds me actually my images, right? So this dot sprites equals, I'm gonna create a little array right here for my sprites. Document get element by ID bird1, because that's the ID that I have right here, right? And then I'm gonna have the next element is gonna be document get element by ID bird2 and document get element by ID bird3. Cool. There you go. So all we gotta do here is I'm actually gonna render the bird. Gotta figure out the size first. So let me go here. Oh crap. I gotta find the file again. I just gotta open it right here. Show in Explorer. Alright. Properties. So it's width 90 by height 64. I think I'm gonna cut that down in half to 45 by 32. No, actually I'm gonna keep it like that because my screen is huge. If you guys want to cut it down, you can. So I'm also gonna give it like this. This dot width equals 90. This dot height equals 64. Now, in here, what I'm gonna try to do is, like normally when you draw an image, here's what happens. If this is the XY coordinate of your bird, let's say that this is, 100 and this is 75 or whatever, and you do draw image at 175, your bird is gonna get drawn like this. Like whatever. It's whatever, dude. Anyway, so what I want to do is basically shift this thing so that he gets drawn right here. And how am I going to do that? I'm going to take whatever the x coordinate is and reduce it by half of the width of the sprite, and then take the y coordinate and reduce it by half of the height of the sprite. So that's where I'm going to render. So I'm going to say let render x equals this dot x minus this dot width divided by 2. Let render y, and obviously I could have done this in a single line of code, but this is more legible. This dot y minus this dot height divided by 2, and x, y, I need to pass the context right here too. This dot ctx equals ctx. So right here I'm saying this dot ctx dot render dot draw image, and I'm drawing this dot sprites bracket 0. I'm just going to start with sprite number 0 for now, and then go on to what's my axis, render x, render y. So that should give me a fallen bird now. Oh no, of course not. I created this whole bird class, right? But I haven't actually instantiated the bird. So I gotta go here, and in my game loop, which I should probably document right now. Before I do any of that stuff, I have to say const bird equals new bird, and I'm gonna put him at 50x to 50y. I gotta pass the ctx right here, and then in here I say bird dot updates, bird dot render, and there's my bird. He's not falling though, which is bad news. Do I have an error right here? Actually, gotta create this guy like a little bit further ahead. There he is. Now let's try to examine why he's not falling. Because in my update, I'm just saying this, but obviously I'm not changing the y position. So this dot y plus equals this dot del y. The y positive is downward, so there he falls. And you notice how he hauls very accelerated, right? So he freaking starts out kind of slow and then hauls ass. And now, what's the plan? The plan is that whenever I press the spacebar key, for example, this del Y thing is gonna get a big negative boost, so it's gonna become like negative 10. And that way, every update is gonna go down by 2, so it becomes negative 10, negative 16, something like that. So it starts going up quickly, but it's because it's slowing down. So the first update after I hit my spacebar, I'm gonna start going up at a speed of 16. But then the next update, the speed of 16 is gonna come down by 2, and the next update, the speed of 16 is gonna come down by 2, and so on and so on and so on, until the speed reaches 0, and then it starts becoming, 2, 4, 6, 8, and falls down really fast. So that's the plan basically with this. I'm going to try something new right now. I'm going to try adding the event listener for the bird in the constructor right here. So document, add event listener, key down function, and right here I'm just gonna log the event so I can find out what spacebar is. So what's the key code for space? Key code is 32. So if e.keycode is 32, what I'm gonna do is what should I do here? Well, when this function runs, I can't use this in here. I can't say this or anything. Why? Because when this function runs, it's going to run as a response from an event. So the window the object who will own it is the window object. So check this out. If I check this out, console.log this. So if I hit spacebar, document, not window, document. So document is the object that owns this thing because he's the one that fired the event key down. If I put window here, I think that'll work too. And window is the event that owns, window is the object that owns this event, so window is the object that fires this function. So I can't use this in here. I have to, there's a couple of things I could do. Number one, I can alias, so I can say var self equals this, right? And then use self in here, self dot vel y equals to 16, and let's this. Let me put a console log statement here. Spacebar. Dang. Negative 32, so he goes up there. There, so we have our jump now. It's actually looking kind of sexy, I'm not gonna lie. So 32 is probably too much. Let's try to do 16, and I think this is too much too. 1.25. Ah, crap! Changed it wrong. 32. There we are. So our Flappy Bird is shaping up pretty nicely. The next thing we gotta do is, I mean, whatever the hell we want to do, but we can go ahead and start by animating this thing. And how do we animate things in here in games? Basically, the way that we animate things in games is by cycling through these sprites. We go here every time we render, right? We should render this, then render that for like a few frames, then switch to rendering this for a few frames, and then switch to rendering this for a few frames. But how do we do that? Because right now we have this update function that basically runs every single frame. So how do we skip a frame? The common pattern to do this is to keep track of your ticks. So um, you give your object a ticks or update number variable that starts at 0. Every time you update, you do this dot ticks plus plus, right? And then you also need, I guess you need a this dot sprite index equals 0. When we render based on this dot sprite index, right? And now the ticks construct is going to help us decide when to increase sprite index. So if this dot ticks mod, let's say every 15 updates is equal to 0, then this dot sprite index is equal to this dot sprite index plus 1 mod this dot sprite dot length, so we don't go out of bounds, right? And there we have it. Our bird is Flappy. I'm actually gonna stop the gravity for a second so that we don't where's right here. I'm gonna stop the gravity for a second so that we see the animation. There it is. That's a beautiful animation right there. And I'm also going to go back to our game and make him spawn a little bit closer to the center. Yeah, that's much better. Maybe actually perfect. Word. Alright. Cool. So now that we have that, we have our bird. We gotta bring this back. Now the next thing is those pipes. So let's go ahead and go back to index.html, create that pipe construct. Script src equals js pipe section dot js, and you know what? I'm gonna say pipe dot js. Yeah. Okay, so I'm gonna go ahead and create that file. Let me go ahead and take a break here for a second. Alright, so let's get back to this. I have, what I'm going to do with the pipe is I'm going to draw it all manually. So I'm going to start const pipe equals function, and it's going to take a position, it's going to take a length, and the context. So this dot position equals position, this dot length equals length, this dot ctx equals ctx. Then for update, I'm going to have it empty for now. Pipe.prototype.update, because I mean that's easy. It's just going to be moving. Actually, I should have a this dot speed equals speed. So basically, the pipe is just going to be moving on the x-axis negatively at a rate determined by this guy. So pretty straightforward, pretty simple, the update function, but it's going to make it difficult for me to see what the hell's going on. And let me explain my reasoning with this. So pause. I think, yeah, I can't think of any way around it right now. But if this is my viewport, right, there's essentially two types of pipes. One that starts there and goes here, and one that starts like here and goes down there. So I need to have some kind of way that the position of the pipe, you know, it's either 0 or like 500 or whatever. So those are the two main considerations for a pipe, and Again, the update is just going to be the pipe is going to move this way by an amount determined by its speed property, and the render is the one that's going to be tricky, because I'm gonna just do I'm just gonna do native canvas stuff instead of an image render. Okay. So let's go here and look up this thing right here. Okay, so this is my color right here, and there's a thing that Canvas has that allows you to basically save the state of the canvas. And if you're going to be changing a lot of colors, I recommend always that you save and restore. So this .ctx.save is going to save the state of the canvas, all the fill colors, all the stroke colors and everything, rotations and all that kind of stuff. And then this .ctx.restore. So you save it right here, because in here we're going to be doing stuff like this .fill, this .ctx.fill style equals right here. This, we're going to be changing the fill style several times, and actually, you know what? Before that, this .ctx.fill style is equal to, I'm going to say, black. Crap. So that I can go here and say this .ctx.fill rect, this .pause, this is x, okay, so I need an x and a y position, obviously, so I didn't think this through very well. My position, yeah, I was thinking initially that position would be a string, like top or bottom, but that doesn't make a whole lot of sense, so I probably better make it a number, and I call this y pos, and this is y pos. This dot x pos is equal, we'll pass it in here too, x pos is equal to x pos, and so fill rect is this dot y pos, x pos, this dot y pos, this dot no, this dot nothing. Let's just hard code a width. Let's put 150, and this dot length is the height, right? So that's gonna fill it in black, and basically after I make it green, all I have to do is this dot x pos plus 3 over 5, let's say, and then the width is going to be 140, and this dot y pos is going to be the same. Actually, this dot y pos plus 5, and this dot length minus 10. So let's see if we can add this sucker now to the game. So const pipe 1, this is temporary obviously because the pipes will be randomly generated. Pipe 1 equals to pipe, what's the constructor like? Should probably do xpos first, ypos after. Length bctx. I'm just going to copy this. So my xpos is going to be 600, ypos going to be, let's do 20 right now to try it out. Length is going to be 200, speed doesn't matter because I'm not using it, and ctx. And then here I have environment, bird, and the pipe. Actually, I'm gonna do the pipe right here. Pipe 1, update, pipe 1 dot render. Unexpected token there. Okay. Wow. Cannot believe I did that. Pipe update render. Okay. Let's see. Update and render. Gotta figure out why the pipe is not coming out. Let's see if this is coming out. So it is coming out. Let's get back here. Have environment update and render. Pipe 1 update and render. Bird 1 update and render. Try to take this out real quick, and then instead say this.ctx.fill style equals back to white. Oh shit. There. That's a problem that we had. We're not ever defining white box, so it was drawing at an undefined place. Alright, cool. Now that we have that, we can actually go ahead and, for the sake of testing this a little bit better, instantiate that pipe 1 out of 20 but at -5. And that way it comes out like right there. Now obviously it's not moving to the left, which is fine, it's part of the plan. I'm gonna go back there. I want to put it a little bit further away for now though. Okay, so that's part of the plan. And now let's test. We have to basically have an auxiliary function that generates a pipe, like a whole pipe with an opening. So let's go right here. We're gonna say function generates pipe generate random pipe, and in here we're gonna say bar or let length 1 equals some amount between 100 and, so let's think this through. So let's say that this one, the top one, the minimum length is 100, maximum length is, the total height of my canvas is 600, so the maximum length right here should be like 400. Then let's say that my opening is 180, right? And then the bottom one is, so there should be like 300 maximum. So that then the bottom one is 600 minus top minus 180, and that's how we compute bar length top equals math.random times 200 plus 100, and then I put math.round right here. So this is a random number between 100 and 300, and then let length bottom equal to 600. Yeah, 600. I'm gonna hard code that 600. That's not good practice. I'll probably refactor that later. 600 minus 180 minus length top. Okay. Now, on the pipe. Okay. So let me think. What I want to do here is basically just return two random pipes. Random pipes. Yeah, that's what I want to do. Return two random. Return. Yeah, two random pipes. So, or return an object with a top and a bottom random pipes. Yeah. So anyway, I'm gonna say right here. Let return val equals top is nothing, bottom is nothing, right? And then return val dot top. Actually, I don't even really need that. I just want to show that so that the students see what it's going to end up as. So return val dot top is equal to new pipe, generate random pipes, CTX. It has to be the CTX new pipe, and it's going to be CTX X start. Okay, it's going to start at X start. Y is going to be -1, and X start is so that I can configure where it starts, so I can hard code. Like, I don't have to hard code, and I might as well not hard code this. So canvas height. So canvas height is a variable that I'm going to pass. That's the canvas height, and X start is a variable that I'm going to pass. That's basically where is the canvas width, essentially. Where's the pipe going to start? Where's the pipe going to spawn? So it's going to spawn like at the edge of the canvas width. Maybe I should just call it canvas width. Yeah. Width. -5, and then return val dot top. Width is 200. That's fine. No, that's not width. What is that? Length. Okay. Speed and CTX. Speed. Let's put like 3. And length. Let's put length top. And return val dot bottom is a new pipe with. It's gonna spawn a canvas width, yes, and the length bottom is equal to that, and then the top coordinate is canvas height plus 5 minus length bottom. Okay, that should be good. So now, what do we want here? Now we want these to actually start moving. So we want these to say this dot xboss minus equal this dot speed. Let's see what that looks like. Okay, that's way too fast. Um, so let's see what we pass in here. .js, pipe 1, definitely not 20. Let's try 4. Okay, that's reasonable. So this one's gonna be 4. Speed also. Speed. Alright. Now instead of this and this, what I wanna do is const pipes equal an array. Okay. And I'm gonna say right here for actually pipes dot for each function pipe. Pipe 1. So I can use the same variable name. Alright, so I'm calling update and render on each pipes in the array, which is no pipe right now, right? However, what I can do now is this. Before or after game loop, it doesn't really matter. Don't really need this now. Okay. Set interval function, and I'm gonna put every 3 seconds. I'm going to say pipes dot push. Actually, let pipe set equals generate random pipes. Generate random pipes with ctx, and right here c dot width, c dot height. Yeah. Pipes dot push, pipe set dot top, and pipe set dot bottom. Let's see. Nothing. Oh. Okay, length bottom is not defined. Right here. Yeah, so I should probably that's fine. I'll just do it every 1 second right now that I'm testing. What was the line with the problem? Length bottom is not defined. Read property top of undefined. God dang it. Oh. Yeah. Return val. Yeah, there we go. So obviously, that 180 is not working out too good. Obviously, this takes a lot of tweaking, you know, with the how high, like what the velocity of the jump should be, what the space of the between the pipes should be. I think I'm gonna open up the space of the pipes a little bit more. So this will be 200. Definitely the interval has to be much longer. The interval has to be okay. So the last thing we need now is like some, I mean, we need some minor things. We need like a score counter, a collision detection. We need our Flappy Bird to like tilt when he falls, because right now it looks very rigid and stiff, and he should like rotate a little bit upward when you hit spacebar, and rotate a little bit downward with the update as you fall down. What else? Scorecard, and obviously score and collision detection. So score, rotation, collision detection are the main features that we should have. And I think I'm going to do collision detection and then call it a night. So how do we do collision detection? There's a couple of different ways. I think we could just write a function right here, somewhere here, to detect collisions, something like this. Function detect collisions bird pipes, and basically what we would do in that instance is we have our bird right here, right? We figure out like a collision radius. I would estimate it would be like, it's about 64 tall and 96 wide. So the collision radius, actually, yeah, the collisions are going to be happening like this. So the collision radius would be 32, and then we have to check if this point right here we can check if this point right here is inside this, anywhere inside here. And how will we do that? Well, we would have to look at this coordinate right here. Let's call this x0, y0, and look at this coordinate right here. Let's call it x1, y1, and this is alpha, beta. So when do we have a collision? When alpha is greater than x0 and alpha is less than x1 and beta is what, less than x0, I mean y0. We don't have to check y1 because y0 is equal to y1. So actually I could just relabel this y0. So under this condition we have a collision with the top, and under this condition, let's call it A and B. This is A comma B. So when do we collide with the bottom? When AB is somewhere in here, right? So the condition of collision with the bottom is that A is, let's call this x2, y2, and x3, y3. So A is greater than x2 and A is less than x3 and B is greater than y2. So those are the two conditions for a collision. Basically, not 100% perfect, right? Because this tip could like maybe hit right here, and then the gravity would take you down and allow you to survive. But that's fine. I mean, if you want a perfect collision, you would basically have to test the radial distance between the center, get the radial distance between the center and all of these points right here in a for loop. That's way too hard. It's not way too hard, but it would take me like an hour to figure out. I'm doing this on the fly, so I don't want to do it right now. I just figured this part out too. This should work, so that's what we're gonna do. Detect collisions for actually pipes that for each bar let collision detected this is where allocation would have come in handy for the pipes. Like if I had a string in there somewhere in here saying that this is the type of like high pipe or low pipe, that would come in handy. But I guess I can detect that by just saying let high pipe equals e dot close this real quick. Y pos is less than 0. Y pos is less than 0. So if the y pos of the high pipe is like this, right, -5, then less than or equal to, let's say, just in case I decide to change that later on. So now I can just say if high pipe and trying to think of the most understandable way of building this. I'm just gonna say here if or let x0 equal e dot xpos let x1 equals e dot xpos plus, I guess I have to hard code the two. I hard coded the 150 right here, so I gotta stick with that. I'm just gonna do it like this. This dot width equals 150. This dot width. Alright. So e dot width x1 so the x is the same regardless. I just noticed that the x is the same regardless of whether this is a top or bottom pipe. So I'm just gonna say this is x0 and this is x1. Cool. I'm just gonna move this out of here. Okay, so I have my x0 and x1, they're the same thing. And if high pipe, then let y0 equal e dot y pos plus e dot length. E dot length, yeah. Right? And then here, I gotta say if now I gotta figure out the bird position. Let out a is equal to bird dot gotta open up this thing. Bird dot x and y, okay. Bird dot x at b equals bird dot, I'm gonna call these use alpha and beta so there's no confusion. Alpha and beta. Bird dot y minus bird dot height divided by 2, right? And if, now I have everything, if alpha is greater than x0 and alpha is less than x1 and beta is less than y1, which, well, y0, then y0, then right here we can say collision detected equals true. And I'm actually going to change this for each so it doesn't run through the whole thing. I'm going to create a regular for loop. For var I equals 0, I is less than pipes dot length, I plus plus, let E equal pipes at I. Okay. Collision detected equals true, and you know what, I can just return true. Now, if it wasn't a high pipe else, then what do? Let y, what did I call it here? y2 equal e dot ypos. Let a equals bird dot x. Let b equal bird dot y plus, this is not minus 2, it's divided by 2. Bird dot height divided by 2. And then if a is greater than x0 and a is less than x1 and b is greater than y2, return true. And then right here I could honestly just return false. That's a bit of a cumbersome function. This right here in particular, nested ifs, always a stinky smell. But I think it's actually, it is a stinky smell, but I think it's actually easier to declare all these variables beforehand than putting if high pipe and, you know, bird.x greater than x0 and bird.x less than x1 and bird.y minus bird.height divided by 2 less than y0. Like, I mean, I think it's less than this thing. I think it's easier to read this way. So now in the main loop, what we can do is before, after update and render, I'm not sure where it's gonna work better. Let's try it here. Detect collisions, bird pipes, and we can do this. If detect collision bird pipes, alert, you lose. We have some errors. Let's put the token. Oh shit. I took away the for each and I didn't take away the parentheses. instead of that alert for you lose. Damn it. I have to be able to get past one to make sure that it freaking works, man. Oh my god, dude. Oh my god. Alright, look. Here's what I'm gonna do. I'm just going to, in the generate random pipes, I'm gonna make that the minimum right here. I'm gonna make it 50, and this I'm gonna make 300. There we go. Alright, there we go. Now we're in business. Now we're in business. There we go. I mean, that's a rudimentary version of Flappy Bird. That's just about finish. All it needs is finishing touches. So that's kind of for our students to take it to that next level and really understand the code. You feel free to go ahead and add a score. Um, and when would you add a score? In the update method of this guy, there's a couple of optimizations that you could do because the pipes are ever growing right now. So in the update method of this guy, you could go ahead and if the x coordinate of it is less than 0, right? Or less than negative the width, go ahead and remove them from pipes. So destroy them and go ahead and add 1 to the score of the game. So you can do that too. You could draw text on the screen for the score. You could add sound effects. It's a lot of different things you could do.